Okay, my distribution x then is a binomial 50, 0.7. So n is 50 and the probability is 0.7. So when I look at my table to try to locate that, probabilities on this page here are going from 0.1 to 0.9, so I can't find 0.7 there. Similarly, that row is all 0.01 to 0.09. This row, 0.1 up to 0.5, is not there. One page over. Probabilities here, 0.1 up to 0.5. And the last page is only going from 0.1 up to 0.5. Okay, so the tables then, I'm only able to access probabilities up to 0.5. So I need to rethink this question now then. So if x has a probability of success of 0.7, if I then think of the same distribution, only instead of the distribution for success, I do failure. So if success is 0.7, failure would be 0.3. So now I'm looking for n is 50 and p is 0.3, and I can find that in the tables. N is 50 and p is 0.3. So this row here will calculate probabilities for me for the failure. So part A, probability that x is equal to 30. So I want 30 successes. Well, 30 successes out of 50 is the same as 20 failures out of 50. So probability x equals 30 is the same as the probability that y is equal to 20. Now then, to get y equal to 20, that means I look at 0.3, and where I'm getting these values from, there's 0.3, n is 50, so my answers are coming from this list here. Okay, now then, you might wonder why these values stop at this point. Okay, so these tables have been made to 4 decimal places. There are values for all these numbers here, except they're much smaller than what we're dealing with here. Okay, so they'd be rounding to 0 if I was going to 4 decimal places. Okay, so I want y equals 20. So to get 20, if I think now of my y values and the probability that y equals y values here will be 0, 1, all the way up to 50. I want 20, so let's just put in 19, 20, 21. There's lots of, obviously all the numbers from 0 to 50 would be there. Now if I want it equal to 20, if I look up 20 in this table, which is 0.0848, if I look up 20, then that means 20 or more. So all those values from 20 up to 50 add up to 0.0848. Because I want it equal to 20, what I need to do then is take off the values from 21 up to 50. And if I subtract those, I'm just left with the value of what 20 was. So coming down to 21, reading that value off from 21, that is 0.0478. So the probability that y is equal to 20 is 0.0848, take away 0.0478, and that gives me 0.037. So the probability of having 20 failures is 0.037, which is exactly the same as having 30 successes. Okay, so I have to change, I have to change the question round if that probability is bigger than 0.5. if I'm using tables, if I'm forced to use tables. If I wasn't forced to be using tables here, I would just be using the formula and finding out x equals 30. Okay, the second part, is asking me to find the probability that x is between 25 and 35. So now I need to change that to y. Well, 25 successes will be 25 failures. And 35 successes means 15 failures. So these are going the other way on the inequality. Okay, so I want to find x between 25 and 35. So success between 25 and 35 is exactly the same as failure between 15 and 25. Okay, I'm subtracting these away from 50. So between 15 and 25, so now I look at my tables, probability that y is between 15 and 25. Okay, so that means on this year, if I go 14, 15, 16, then to get between 15 and 25, I want to have 15, 23, 24, 25, 26, and I want to have 25, so that I want to know what that adds up to. Okay, I want that total amount there, all those values. So if I look up 15, I get from 15 all the way up to the end. And then if I look up 26 up to the end, then I'll have the values from 15 to 25. So it's the same as then probability that x is greater or equal to 15, take away probability x is greater or equal to 26. So I want that 25 to be included. So look at the table then. 15 is 0.5532. Take away up to 26, so coming down to 26. Going across to my table, which I've highlighted, is 0.0009. Calculating that, 0.5532, take away 0.0009, and that's 0.5523.